Hi, my name is Ricardo, and I'm your host of Math Matters, and today I'm here to talk to you guys about probability. Now, probability is defined as the likelihood of an event to occur. It's usually introduced in elementary school math courses, reinforced in middle school math courses, and then possibly further reinforced in high school curriculum, still involving math. But I'm here to tell you that probability is not inevitably associated with math. The reason that probability is useful in our everyday life is because it can be associated to a nearly infinite number of different scenarios, different events that we can enumerate. But in order to understand probability fully, you need to know the mathematics behind it. And that's why we're going to define some terms first. So, in math, the probability of an event occurring is written as the probability P of an event where A is our event. So, the probability of event A occurring. So, P of A is calculated by a fraction. So this is when we get into the calculation of our probability. The calculation of our probability is the number of ways A occurs divided by or over the number of total outcomes. And that's essentially how probability is inevitably based in mathematics, but it doesn't have to be inevitably associated with mathematics when you talk about a general probability. But to get to the probability, to calculate it, you need to know the math behind it. So usually the first example of probability that people are taught, the first example is flipping a coin, right? You can flip a coin, you have two different options, two different total outcomes, and one that you're counting. But to make it a little more interesting, I want to use a six-sided die. So our example is finding the probability of something on a six-sided die where there are six options. I wrote them out, 1 through 6. The die has 6 sides, and you're trying to count some kind of event that occurs. So let's say I want to count the probability of 6, P6. This means the probability of event 6 happening. The probability of me literally rolling a 6. Now the probability of me rolling a 6, this probability is calculated by the number of ways rolling a 6 occurs. Only one way. I can't roll a 3 and say it's also a 6. There's only one side that can get me a 6. One side that satisfies this event. 1 divided by the number of total outcomes. Now, as I wrote them down here, there are 6 total outcomes on a 6-sided die, so our probability is 1 over 6. Now, probability is not always defined in a fraction, even though it is inevitably calculated as a fraction. It's not always given to people as a fraction, not always presented this way, because sometimes it's more convenient to present it in one of two other ways. The first of which is a decimal. Now, the decimal form, when you divide it out, is literally 1 divided by 6 on a calculator. It will tell you this is 0.183. I'm repeating, but I'm just going around it to 3 decimal places. So, 1 divided by 6 is 0.183. Now that doesn't mean as much as a fraction necessarily, because when I have a fraction I can tell you how many times it occurs for how many different events, but a decimal is just a number, and it doesn't make a lot of sense to me. So we're going to try to make some sense of this. The way decimal works is, and the way percentage works, we'll talk about that in a second, is we have a scale from 0 to 1. So these decimals can be any number within the scale. And 1 is a certainty. And in fact, it's certainly true, the event. So whatever our event is certainly true. Whereas our 0 as a decimal is the opposite. Certainly false. Okay. So, our 0.183 false somewhere in here. It's more likely to be false than it is to be true, right? That makes sense because the probability of rolling one of the sides is 1 divided by 6, and I wouldn't bet all my money on rolling that. That's not a high enough probability because it's closer to the false than it is to the true. That's the fraction. That becomes a percent, a decimal. But it also becomes a percent which is a very common way of presenting probability. How does it become a percent? Well, once you have the fraction, it's very simple to make it a percentage. All you have to do is multiply by 100%, where percent means per, literally meaning for, cent being the root of 100. So percent means how many times would it happen out of 100. So it's a fraction where you force the denominator to be 100. You multiply it by 100 and you get this number. Here it's 18.3%. Neat little trick, when you multiply by 100, you can move the decimal places 2 over, and that gets you your percentage. So this percent is a great way of comparing every single probability, because when you compare it out of 100 different chances, so every 100 options you get about 18.36s. That doesn't mean a lot necessarily, but you can compare it to, let's say, getting a 5 and a 6, or you can compare it to the rate of, a success in a medical surgery, and you can compare it to any different kind of event that doesn't have to be related at all to this event, but because they're all in percentage, all these probabilities are easily comparable. That's not to say that they're not comparable as a fraction or in decimal, because they're easily comparable as a decimal, right? They all fall on the scale, and they're easily comparable as a fraction, but with a fraction they'll have different denominators. It's hard to compare fractions like 1 over 7 and 1 over 6 with different denominators. It's hard to add those, etc. And with a decimals are sometimes far too complicated. So percentages are usually the best way to compare different probabilities, and that's usually how they're presented. Now, if 0 to 1 is our decimal scale, our percentage scale would be 100 times that. So 100 times 0 is still 0%, right? Versus 100%. So 100% means something certainly true. Like if I'm 100% about an event happening, I know it's going to happen. Versus if, this is a bit grim, but if there's a 0% success rate, then I know it's not going to happen no matter what. However, one thing that's very important about probability is that it doesn't predict the future always. So if I tell you that the probability is 1 in 6 to roll a 6, I'm not telling you what's going to happen when you roll the dice. I can't tell you that. I can't predict the future. That's not the point of probability. The point, however, of probability is to predict over a large scale of total outcomes, where we have several different rolls in this case, what would the probability tend to be? So how often would this tend to happen? 18.3% of the time, about. So no matter how many times you roll it, you'd expect it to be this. That, however, doesn't mean that you roll a 6 18.3 out of 100 times. There's no way that can happen, right? In fact, you could roll a 6 every single time. You could roll a 6 100% of the time, and that's so far from our probability, but this is because the probability does not tell you exactly what's going to happen every roll. It tells you, when you have a large enough sample size, what you would expect to see, and that's the usefulness in probability. Hi guys, thank you so much for watching my video. It really does mean a lot. And if you enjoyed this one, I encourage you to watch the next video in my series. And hey, if you're done with the series, there's always more mathematics to learn. Because remember, math matters.